let's get started. First Wi-Fi in Nomad session. So what is the reason? Why do we need to use this? And what happens if you're not using 802.11w? Joining. Let's just give a couple of minutes everyone to join.
Yeah, we see a lot of people joining for this. I think we'll wait for one more minute and then we can get started. Yes, good evening. So 2 minutes past 4:30. I think I'll just give a few words about this Wi-Fi Nomads community. So it's right from the start, we have been seeing a great enthusiasm from the inter Wi-Fi professionals across the globe. We see active contributions thanks to all the contributors who actively ask questions, gets the clarifications, and all the experts who tries to help each other. So the learning and sharing the learning, and through that we are learning more from the community, and this keeps happening. And this is something the very next step which we are trying to do, that people are actively coming out from the group, willing to share the knowledge to the Wi-Fi community. So this is a free session where people can actually contribute. If you are expert on any area, and if you think that you can share your experience on any field which relates to the Wi-Fi, please reach out to us. We can help you to organize the things by adhering to our Wi-Fi Nomads community, where we don't want to share any sensitive information, any information pertaining to company or anything which is confidential. And by adhering to that, we can continue sharing and helping the community to grow and bring better version of ourselves. So having said that, I think stage is yours, Gopi. We can start our first session on 800.11 WPMF.
Yeah. Thank you, Vishnu. Thank you all for joining. Okay, all right. Let's get started our first Wi-Fi in Nomad session on 802.11w. Let me just share my screen. Okay. Okay, 802.11w. Hope you like the rhyming. Thanks. Okay, 802.11w is mainly used to encrypt the management frames, right? So which is used to protect from attackers, from frame injection attacks like spoofing attacks, right? So this is introduced by IEEE and in WPA2 and WPA3. So what is the reason? Why do we need to use this? And what happens if you're not using 802.11w? So basically, PMF means protected management frames. It is used to protect the frames. Okay, the problem, which means, so you can say there is an enterprise office, and there are employees connected to an access point, right? And they're doing their job, right? So an attacker who is having minimal knowledge on Wi-Fi and is having network adapter which can actually send packets into the air, right? So can call it as spoofed frames, right? So what actually this attacker can do is, so he can get the beacons, right? He can sniff the beacons and he can see the data. I mean, he can't see the data because that's encrypted, right? So but he can see the beacons and he can get the MAC addresses of clients and access point. So he will get the MAC address of access point and create a authentication frame, like spoofed frames. So and send it to the air, right? So if he will just flood into the deauthentication frame into the AI. So which can actually cause clients to disconnect from the network, because clients will think that access point that the deauthentication frame is actually coming from the access point, because the MAC address of the frame is same as access point's MAC address. So these clients will disconnect and they will lose their connection, right? This is called as denial of service attack. Hope you all know. And so not only just these types of attacks. So if you go to YouTube and search how to hack Wi-Fi, right? So you can see lot of videos which are similar to each other. What they will just do is they will just disconnect a client from an access point, and the client will try to reconnect again. So while the client is trying to reconnect, they will capture the four-way handshake by using that four-way handshake and some word list. So they will just do dictionary attack. So if they are lucky, if they are having passphrase, then they will get the passphrase, and next they will do post exploration, right? So there are a few attacks, evil twin attacks. So evil twin attacks. So the attacker will disconnect clients from the original AP and tries to connect those clients to attacker's AP, who will create spoofed access point, right? And those clients will directly connect to the attacker's AP, and he will just get all the data, right? So these types of attacks will cause a lot, right? So it will affect a lot, and DOS attacks is one of the main reason, right? So how we can avoid? Before getting into that, let me just show you the demo of this attack, right? Okay, so let me just open my camera. Yep. Hey. So here, so I can't create an enterprise network here because I don't have that money claim. But here with me I have a network tool which can actually create 100 clients, more than 100, how many clients you want. But in this, for this demo, I will create 100 clients. So hope you can see this, right? So using this, I can create 100 clients and connect to the access point. Here is an access point and here is clients, right? So I will just create and connect and run some traffic between the access points and clients, right? And in the okay, here is an attack. So I have this network adapter which can send packets into the air, right? Okay. So I have used some Scabby to create the authentication frame, and using this adapter, I will send this to air. Okay. So here the user interface of the network tool. So here I have connected 100 clients. You can see these are the 100 clients connected to that access point, and let me just run some traffic between the access points and clients. Okay. And here you can also see in the controller UI of an access points. Here you can see the association clients. Now all these clients are connected to that access point, right? Okay. Now the traffic is running. So now let me introduce. I already introduced, right? So okay, let me just open my tool called Kali, and I just wrote a script which I can show you right now. Okay, using this script. So here is the source MAC address. Source MAC address, AP's MAC address. Okay. And the destination is broadcast address. So this frame will be broadcasted to everyone, okay, from the AP. Okay. And it is a deauthentication frame. Okay. It's a deauthentication frame and with the reason code 7. You can use whatever code you want, right? Okay. Let me just send this frame. Okay. The packets are sending and let's check the clients are disconnecting or not. Yeah. Here you can see the clients are disconnecting from the access point. How you can say is see here the supplicant logs where even these clients are trying to connect again, right? So this is a for loop, right? So this code will keep on sending deauthentication packet into the network. So the clients will continuously disconnect. This network got interrupted, right? Even if you see the throughput got affected, right? So hope you understand this now. And let me show you the frame, how it looks like. So it looks like similar to same deauthentication, how AP sends, right? Okay. It is okay. So if you observe these deauthentication frames that I have created, which is not even having radio information in it, and it's a deauthentication packet, you can see, and it is actually looking like a normal deauthentication packet from the AP MAC address, which is actually disconnecting this client. Okay, let me stop this script. Okay, what is the solution now? So you have seen that interruption in the network, right? So what is the solution here is at 2.11w. So how you can protect your network using this 2.11w is by protecting by encrypting this management frames. So not all the frames will be encrypted. So the frames which will come after completion of four-way handshake, because because only completion of four-way handshake you will get the keys like PTK, GTK. Now in this case high GTK, right? So you will get those keys. Using those keys can encrypt the management, which are deauthentication, dissociation frames, some action frames, and channels which announcements. So actually these frames will be encrypted. And so if it is a unique hash frame, it will be normally encrypted at PTK, how data frames are encrypted. And if it is a GT broadcast frame, which you have seen now, that the deauthentication is broadcast, every client will disconnect it, so that will be encrypted by IGTK. So using 11w, so we can encrypt. So when client got that frame, so if you see, so even in an 11w enabled case, so when an attacker tries to flood a deauthentication, the client won't disconnect from the network, and they will just reject the frame. So it will, they see these are the supplicant logs. When a client receives frame, unprotected frame, it will say unprotected. I don't want, I just want to drop it. So they will just drop the frame, right? So okay, let's enable this on AP, and we'll just do the same attack, right? I will change it to required from AP side. I will just save it. Let me just disconnect this all the clients and connect back. Okay. Okay, I'm just disconnecting all the clients and I will connect back. All right, all these clients are disconnected. Let me just connect back this again. Now these clients will be connected and the 11w is enabled. Now the management frames will be encrypted. So there are so for WPA3 it's must you have to enable 11W. So if the client doesn't support it, it won't connect. So for a WPA2 encryption, so you can set it as a optional. So if client supports, if some legacy clients may not support 11W, so even the clients can connect, but so for those clients, the management frames won't encrypt, so will be plain text, right? Okay. So from client side, it's an optional, and so they will this client and the AP will accept, and they will just connect, and the frames will be encrypted. Okay, looks like all the clients got connected. Okay, let's give the client. Okay, this will take some time. Okay, the clients got connected, and we'll just do the same test. Just run the same deauthentication flood. Okay, all these clients got connected. Okay, okay, let me run this script. You can see the packets are going. Okay, you can see that the authentication packets are going, and let's see the clients are disconnecting or not. See, you can see that, and the traffic is clearly, there is no drop in the traffic. The clients are not disconnected. So if you observe these supplicant logs, you can see this frame, this unprotected authentication frame got from this MAC address, but is not protected. So client will just drop those packets. All right. So using this way, we can actually protect our network. This is one of the way to protect our network. There are many ways, and yeah, this is one of the way. Yeah, all right. So I just mentioned that here, so we can only encrypt the frames, deassociation, deauthentication, few frames, which we can, which will get after completion of four-way handshake. But what about the frames which comes before four-way handshake, like authentication frames, association frames, right? So there are frames which. So what client will do if it gets spoofed association request? So from the MAC address which is already connected a client, right? So how AP will do? What AP will do, right? So let's look into that. As a query process, security association query process. So here in this case, imagine, so it's a original client connected to this access point with this MAC address. Okay, now attacker trying to send a association request using the same MAC address of already connected client, right? So now AP will think, oh, I already have this client, so why this client again sending? Okay, let me just reject this association request for some time and see what will happen. So and it will provide some comeback time, means you can just come after this time. So the comeback time is depend on vendors. So so in the comeback time, the AP will send SA query request which is encrypted the PTK key. Okay, so only original client decrypt and can respond to that frame. Okay, so in the comeback time, AP will send a query request, and original client will respond to that request. Okay, now AP will think, oh, the original client is already connected. Now I got a frame, association request frame from an attacker, so I should not give access to him. So this process will continue all the time. So even if a attacker sends, this process will keep on going. So this is called SA query process. This will be this will be done when you enable 802.11w on your AP, right? So this is the scenario one. So assume a client, original client disconnect without sending the authentication. So the client here already connected with this MAC address and is disconnected without saying goodbye to AP, right? So without sending any deauth or this dissociation frame to the AP, this may happens on when power off suddenly, right? So those are the cases. So the client may disconnect from the AP. In this case, AP still thinks that, hey, this client is already is connected, right? So, and after some time, client recovered from the failure and he'll send a association request, right? So AP will think that, so this client didn't disconnect. I didn't receive any deauthentication frame from this client. So maybe this may be an attacker's phone, and do the same thing. So he will send reject association reject frame and provide some comeback time. So within that comeback time, AP will do again the same process as a query request, and it will send, it is encrypted with encrypted PTK. Only original client can respond. So here no client will respond to that because the original client is already got disconnected, right? So after completion of comeback time, original client will all again sends the association request frame, and now AP will think, okay, last time I didn't get any response, a query response. I think this is our clients maybe disconnected without saying goodbye to me, and I can give access to this. Okay, and this will give the access. So now both will connect. So this SA query process will be done when you enable it 11W only. So, yep. Any questions?
Thanks, Gopi, for the very insightful session. Anybody have any questions on this to shoot out to Gopi? I think there's a question in the chat. You can post the question in the chat if you have any questions. Yes, we will share the content in some format, either in Google Drive or someplace where we can actually share it, or even in the WhatsApp group. So we'll share the presentation slide. Yeah. So if you don't have any questions, so moving forward, probably we can actually start a Google Sheet link and we will share it across. If there is any presenter who is interested to present some topic, we can add that there, and we can plan out the dates for it, and we can actually share this to the community. If there is no further questions, thanks everyone for joining, and keep making the community live. So keep going. Thanks. Everyone.
Thanks, guys. Thanks, everyone.
Thanks, guys. Thank you. Bye.